you tired of managing dozens of VPCs across different AWS accounts? And does your network architecture look like a tangled mess of peering connections and transit gateways? What if you could manage networking for dozens or even hundreds of AWS accounts without creating duplicate VPCs? There's a better way we can easily handle this. This project is Project 37, and today we are diving deep into AWS Account VPC Sharing. In this project, we are building a production-ready multi-account VPC sharing architecture using AWS Organizations and AWS Resource Access Manager (RAM). By the end of this video, you will know exactly how to centralize your network management while giving your application teams the freedom they need. We will cover the architecture, the prerequisites, and I'll also walk you through a complete step-by-step deployment using the AWS Console. Alternatively, you could also use Terraform to deploy this project. Whether you are preparing for the AWS Advanced Networking specialty, designing enterprise cloud environments, or expanding your cloud architecture skills, this hands-on project will show you exactly how it's done. But before we deploy anything, let's understand the architecture we are building and follow the traffic flow between the management account, the VPC owner account, and then the participant account. Now, before we jump into the architecture, first of all, if you are enjoying these enterprise AWS projects and want to master cloud networking by building real-world architectures, please consider subscribing. Every project on this channel is designed to help you develop practical skills that employers and enterprise environments value the most. So don't forget to subscribe and like these videos. This is the architecture we're going to be building. This architecture demonstrates AWS multi-account VPC sharing using AWS Organizations and AWS Resource Access Manager (RAM). This is a common enterprise networking pattern that allows multiple AWS accounts to deploy resources into a centrally managed VPC without each account having to create and manage its own networking infrastructure. At a high level, the architecture consists of four major components: the AWS organization itself, the owner account, which is going to be the management account, AWS RAM, AWS Resource Access Manager, and then the participant accounts. Think of this like an apartment complex. The owner account owns the lands, the roads, utilities, and securities, and then the participant accounts rent apartments and bring their own furniture so they can deploy anything they want. Everyone shares the same infrastructure while keeping ownership of their own resources too. So at the top is our AWS organization. The job of the AWS organization is to manage multiple accounts, of course centralize billing, apply organization-wide policies, and also enable the resource sharing through RAM. So for us, we're going to be creating an organization, then have multiple accounts in there, and then share the resources. Now, the owner account, this is the network account, and it's going to be our management account. It owns the entire VPC. Inside the VPC, we have two availability zones. Also, we'll have public subnets, private subnets, and then private subnets for our database in each availability zone. So notice that we are just sharing these subnets. The public subnet and the database subnet are not shared. We're just sharing this subnet. And that's what we're going to be sharing here through RAMs and then sent over here to the participant accounts. The public subnets remain private to the owner accounts. The participant account should not be able to deploy into the public subnets. And this is an AWS best practice because participating accounts should not directly manage internet-facing networking resources. Now for the network components of the owner account, the owner account owns all the networking resources. These include the internet gateway, the NAT gateway for the private subnets, the route tables, the ACL, security groups, and VPC endpoints. All is owned by the management accounts. Participant accounts cannot modify any of these components. This centralizes network administration within the owner account. Instead of every account creating its own networking, one team manages it for everyone. So this is how you can now share resources. This, for example, your security team is responsible for managing the account, and the development team wants to deploy something, an application in a subnet on an EC2 instance. So you in your organization can just create one subnet for the development account and then share it with the development accounts in their own account. They can now deploy whatever they want to deploy on it without managing the network of the resources, which makes things easy for them. Now, the RAM, the AWS Resource Access Manager, is responsible for sharing the resources. This is the liaison officer that shares the resources. The owner selects which subnets to share, and then in this architecture, we are going to be sharing subnet A and subnet B. These subnets become available to the participating accounts, and then the VPC itself is not transferred. Only the subnets are shared. Ownership remains with the owner account. The owner account still owns everything. All they are sharing is just the subnets. Once they share the subnet, the participating account can now deploy resources in the subnets. So once the resources are shared, the participating account accepts the share, and now it can launch resources into those subnets. So something very important one should take note is, even though these resources are shared by the owner account, the resources deployed belong to the participating account, the IP addressing belong to the owner account's VPC. Everything exists in the same network, which is very, very important. So because everything lives in one shared VPC, there's no VPC peering needed, there's no transit gateway, there's no VPN, there's no private link. Everything is within the same VPC. Traffic flows directly using the private IP address. Since everything is within the same VPC, you're just sharing the subnets. So traffic never leaves the VPC. It stays entirely on AWS private network, and this helps to improve performance, latency, and security. Now, in terms of resource ownership, this is one of the most important concepts to understand about resource sharing, right? Remember, the owner account owns the VPC, the subnets, the route tables, the internet gateways, the NAT gateways, the security groups, the ACLs, the network ACLs, and everything. But the participating accounts own the databases they create in the subnets. The elastic network interfaces attached to the resources also belong to the participating account. The EBS volumes created when deploying the resources belong to the participating account. Also, the IAM roles created belong to the participating account. This separation allows the networking team and the applications team to work independently, which is a great thing. Now, some of the benefits of this architecture is that instead of every account creating its own VPC, internet gateway, NAT gateway, all the networking components, the organization builds the network once and just shares it securely. And this provides several advantages for the organization. Like it's reduced cost, simplified management since everything is managing the same one VPC, consistent security and scalability, operational efficiency for the organization. So all this helps the organization. The real world use case for this, like I said earlier, imagine in a company with separate AWS accounts for finance, HR, marketing, security, development, production, data analytics, and so forth. Without VPC sharing, each team would need its own VPC, NAT gateway, route tables, internet connectivity, and everything. But with VPC sharing now, the networking team builds one well-designed VPC, shares the required private subnets with the separate departments, and then each department deploys its own workloads while benefiting from the centralized networking, security, and governance created by the networking team. And this kind of architecture is widely used in enterprises adopting landing zone or control tower strategy. It centralizes network management while allowing application teams to deploy resources independently, providing a secure, scalable, and cost-effective foundation for multi-account AWS environments. So here in the AWS console, before beginning the deployment, we'll have to ensure that the following prerequisites are met across your AWS organization. First, VPC sharing only works within an AWS organization. You cannot share a VPC with an account outside your organization. So first of all, you need to create your AWS organization, right? So when creating your organization, which is very easy, just go to AWS organization and create the organization. you want to make sure that you're creating the organization with all features enabled. You must also have access to the management account of the AWS organization you are creating. And you need at least 2 member accounts within the organization. One is going to be the owner account. That can also be the management account, and then the participant account. Second, you must enable resource sharing in the AWS organization's management account. So in the management account, we have to go in there and then go to Resource Access Manager, the RAM, and then enable share resource. And then finally, you need the right IAM permissions. The owner account needs permissions to create VPCs and use AWS RAM, while the participant account needs permissions to accept RAM shares and launch EC2 instances. So in this project, I will walk you through most of the setup. We have already set up my organizations already. But now the first thing we're going to do is go to AWS RAM, go to settings, and in settings, we want to enable sharing with organization. So when you enable this, is going to allow you to share resources in your organization. Let's go ahead and save. There you have it. We have enabled that. Now enabling this setting allows resource shares to be automatically accepted by the participant accounts in our organization, which streamlines the sharing process. Instead of going back there to accept, they automatically accept once we share it, which is good. So now the next thing we're going to do is go to our VPC in the owner account. So right here, I'm going to show you my AWS organizations. I've already created my AWS organizations already. This is my AWS organization. These are the accounts in my AWS organization. I have several accounts. Under Foundation, I have several AWS accounts. Now, this is my management account. As you can see, this right here is the account I'm logged into. This is my management account, and I'm going to use one of these accounts as my participant account. So I've already set up my organization and created an account in there. So I'm done with this part. So the next thing we're going to do, since we've set up our organization already, is now go to VPC and then create our VPC in the owner account. So right now I'm in this account, as you can see. So right now we're going to go to VPC. We're going to come to VPC and then we're going to create a VPC. So here I'm just going to create my VPC easy. So here I'm going to name my VPC. This is going to be the owner VPC. And then for my side, I'm going to use the /16. For the AZs, for this project, I'm just going to use one AZ, not to complicate things. And then for the public subnet, I need one public subnet and one private subnet. And then for the CIDR blocks, for the public subnet, I'm just going to do a /24. And then for the private subnets, let's do 10.0.24. And then we don't need a NAT gateway for this. And then no S3 gateway. And then let's go ahead and create. This is what it's going to create for us with an internet gateway. And then let's go ahead and create the VPC and the subnets. So now that it's created, if you come back to VPCs and refresh, it's created now with our subnets. So the next thing we're going to do is to navigate to the RAM console right here. And then we're going to go to resource shares and we're going to create a resource share. And then for the resource share name, you want to be as descriptive as possible in your organization. If it's going to be the finance team or the HR team, make sure you're very descriptive. That way it's easier for you to remember whenever you see it. And then for the resource type, we're going to be choosing subnets. So subnets, and then these are the subnets we want to share, right? So for this, I'm just going to be sharing the private subnets. So this is a private subnet I'm sharing. So I'm going to select this. I'm not sharing the public subnets. And then go ahead and click next. Here, it's going to be creating the role for us that we need. I'm just going to go ahead and click next. And then for the principals, we're going to allow sharing within our organization, not with anyone within our organization. And if we want to display our organization structure to understand which organization we're going to be sharing with, we can come here and display organization structure, so to know who we're going to be sharing with. And for this, I'm going to be sharing this with the foundation network account, and then go ahead and click next, and then go ahead and click next, and then just review everything. So this is just a summary. This is the resource we're going to be sharing, and this is the managed permissions we're using, and then we're going to be sharing that resource with this principal, this account. And you can see this account is different from this account right here. So we're sharing with this account. Just go ahead and create resource share, and it's created automatically. So now I want to be able to open the two accounts in the same browser. So I'm just going to go over here and I'm going to turn on multi-session support for this account. So I'm going to turn it on. So I've turned it on. This is going to enable me to open the other account side by side. So for my other account, I'm just going to come over here. This is my other account right here. I'm going to go ahead and get into my other account. There you have it. This is my other account. So if you come to resource share here, this is the other account ending in 693, and there it is ending in 693. So there you have it. So now if we go to this account, if we go to VPC and go to subnets, if we come to subnets, you will see that we have automatically, you'll see that there's one that the CIDR block is off, which is going to be this one. And then if you keep going, it tells you, is it default subnet? And it tells you no, right? Was it auto assigned public IP? It tells you no, because these are all public subnets and this is a private subnet. And if you keep checking, you'll see that the owner of this is the 684, which is going to be this other account that shared it, the 684. So right now, let's come into participant account that we created, and then we're going to create a resource. So let's go to the EC2 console, go to EC2. We're going to launch an EC2 and we're going to call this test shared VPC. It's going to be AWS Amazon Linux. We're going to proceed without key pair, and then we're going to edit the network. And then for the VPC, we're going to select this VPC right here, which is going to be the same as our VPC that was shared. And then right here, we are selecting the subnet, the private subnet that was shared with us. As you can see, the owner is still the owner, our other account, the owner account, and this is one that was shared with us, right? And if you come to security group, we're going to be creating a new security group, and we're going to be allowing SSH, and then we're going to also be allowing ICMP. That way we can ping it. So let's allow SSH from anywhere. That's fine. We're going to add another rule, and we're going to allow ICMP IPv4 from, and we can set it to come from the side of our VPC. And our VPC CIDR is the /16, and then leave everything else as default, and then launch instance, and then our instance is running. Now let's go back to the owner VPC. Let's go to VPC. Let's go to EC2. And this is the owner account, right? So we're going to be launching an EC2 in the same private subnet. So let's launch an EC2. This is the owner test instance. We're going to leave everything as default, proceed without key pair, edit the networking. We're going to be choosing our VPC we created, right? And then the subnet, we're going to be going to the private subnet. This is the private subnet. And then we're creating a new security group, and then we're allowing SSH, and then we're going to allow ICMP also from our VPC CIDR. And then let's go ahead and launch the instance. So let's go to instances, and now we have instance running in the owner account, and we also have instance running in the test account. So these two, we have both instances running. Now what we're going to do is to connect to one of these instances and then try to ping the other instance, which will have a connection since they all reside in the same VPC. So let's try that and see. So since these EC2 instances are in private subnets, I'm going to try and connect to them using the SSM session manager. So I'm going to be setting up their roles and then also creating endpoints in both accounts. That way I can connect to them, connect to their private instances securely, and then try and ping them to validate the connection. So let's go ahead and create the rules. So in the participant account, so the first thing we will do is, so as you can see, there's no IAM role attached here. So what we're going to do is go to IAM, and this is the participating account. Let's go to roles and then create role, and this is for AWS services, and this is for EC2, and it's going to be the Amazon SSM managed instance core, and then next. And this is going to be our participant role. Let's go ahead and create role, and then now we're going to go to, still in our participating account, let's go to security group. We're going to be creating a security group for our endpoints. Let's create a security group specifically for the endpoint, and this is going to be the endpoint security group. And then for the VPC, it's going to be the VPC, and then we're going to be adding rule, and then we're going to be allowing port 443 HTTPS. endpoints from our VPC cider. Let's just make it generated from anywhere, and then let's go ahead and create security group. So now that we've created the security group, let's go to VPC, and then let's go to endpoints. We're going to be creating 3 different endpoints. And the first one, we're going to name it endpoint 1 for AWS service. And the first endpoint we're going to be creating is going to be let's search for SSM, and it's going to be the US-1.SSM. Select it, and then for the VPC, let's select our VPC, and then for the subnets, we're going to select our private subnets, and then for the security group, we're going to be selecting our endpoint security group, and then go ahead and create endpoints. And this does not support shared VPCs. Let's go to our owner VPC here. Let's go to security group and create a security group for the endpoints. Let's go to endpoints. Let me see our instance. First of all, I'm going to modify IAM role. I'm going to be creating an IAM role and attach to it. This is going to be the SSM instance role. I'm just going to create and then update IAM role. Now let's go back to VPC, and then I'm going to go to endpoints. I'm going to create an endpoint, and this is going to be 1. I'm going to SSM, go to VPC, select our VPC, and then select our subnets, the private subnets, and then let's select our security group, and then let's go ahead and create. Okay, I guess we have to create our own security group. I'm going to create a new security group for this. I'll name this endpoint 2 VPC, and then for inbound traffic, I'm going to allow HTTPS from anywhere, and then go ahead and create. Now let's go back to our endpoint. Let's refresh, and then let's select our security group here, and then create. So 1 is done. Let's create the other 2. This one is going to be for SSM messages, and then this, and then create. Now let's create the last one, and this is EC2 messages. There you go. So let's check our instance. So now our SSM session manager is active. Let's try ahead and go ahead and connect. So we have shell. We're connected in the instance. Let's go ahead and test the connection. This right here is our owner account, and we have connected using SSM session manager. So here, let's go ahead and ping our participant account. This is our participant account right here. If you go back to instances, this is our participant account in a different account, and this is our instance IPv4. So here we're pinging from our owner account to the participant account, and let's go ahead and ping. There you have it. We have connection. Now let's repeat the same thing from the participant account. Let's go to the participant account and connect using session manager, and let's connect. Right now we're going to be pinging our owner account. This is the owner account P. Let's copy the IP address, come back here, and then let's ping it. So, and this is /50. There you go. This is /50 from our owner account. We are pinging from the participant account, and then let's go ahead and ping. We should have connection. And there you have it. Congratulations. You've successfully built a production-ready multi-account VPC sharing environment using AWS Organizations and Resource Access Manager. In this project, we learned how to enable organization-wide resource sharing, share VPC subnets across AWS accounts, launch workloads into shared network infrastructure, centralize network administration while also maintaining account isolation, right? We also build scalable architectures that align with AWS enterprise best practice. Now, this is exactly the type of architecture used by large-scale organizations managing hundreds of AWS accounts across multiple business units. If this project helped you understand enterprise networking or helped you in any way, give this video a thumbs up and leave a comment with the next AWS project topic you want to see. Subscribe to the CloudGuard portfolio channel for more hands-on AWS security, networking, DevSecOps, AI, and cloud architecture project. Thank you for watching. I'll see you in the next project.